Welcome to Engage New York, Module 4, Lesson 19. This is Concept Development or our lecture. All right, we're going to go ahead and start off with, we have kind of made a switch here. We are converting measures involving whole numbers and solve multi-step word problems. So we're going back to converting measures, units of measurement. So we did this previously, but now we're coming back to it, and it's going to be something that reappears as we continue to go through these modules. Now, let's begin with 30 centimeters is equal to how many meters? So my question for you is, what is the larger unit? Is centimeters or meters larger? Well, meters are larger, right? So this is the smaller unit, and this is the larger unit or bigger unit, right? So we're going from smaller to bigger. So we are expressing a smaller unit in terms of a larger unit. So is 30 centimeters more or less than 1 meter? So think about it. Is 30 centimeters smaller or larger than 1 meter? You're right, it's less than 1 meter. Is it more or less than half of a meter, though? What do you think about that? So it's less than half a meter because 50 centimeters is half a meter. And this is only 30 centimeters. It's less than half a meter because 30 out of 100 is less than half, right? So let's keep that in mind as we work. We want to rename these centimeters using meters. So we're just renaming it. We're taking 30 centimeters and renaming it as meters. So what do you know? So we know that 30 centimeters is the same as 30 times 1 centimeter. Remember how we were working on that previously when we were solving these problems? We know that 30 centimeters is the same as 30 copies of 1 centimeter. So let's rename 1 centimeter as a fraction of a meter. So what fraction of a meter is 1 centimeter? Can you tell me? Do you know? Well, it takes 100 centimeters to make a meter, make 1 meter, right? So 1 centimeter as a, sorry. So 1 centimeter would be 1/100th of a meter, right? So let me write this right here. 100 centimeters is equal to 1 meter, right? So let's go here. Whoops. Let me rewrite this. 1 centimeter is equal to 1/100th of a meter. And we know if we add 100 out of 100 centimeters, so if you had 100 out of 100 centimeters, you would equal what? 1 meter, right? So we're looking at 1 out of 100 centimeters. So that is 1/100th of a centimeter. 1/100th of a centimeter, right? Or let me rewrite this again. I don't like the way I did that. So 1 centimeter is equal to 1/100th of a meter, just like before. So I'm just trying to jog your memory, make you think about relating our measurements into fractions, and then how we're going to look at it with decimals as well. So we are looking at 1 out of 100 centimeters, so that is 1/100th of a meter. So now let's change this to 30 times 1/100th of a meter. So remember how we're trying to change this, so we're trying to change this right here into meters. So now we have to use what we know about meters, and we need to convert it right here. That's how we're going to get that renaming of our centimeters to meters. Okay, how do you know this is true? Well, it's true because we just renamed the centimeter as the same amount in meters. 1 centimeter is the same thing as 1/100th of a meter, right? So now we have 30 copies of 1/100th of a meter. So how many hundredths of a meter is that in all? Well, it would be 30 hundredths, right, of a meter. So writing it out as a fraction, and now how could we reduce that into simplest form? Well, let's think about this for a minute. 3 times 10 and 10 times 10, right? We can cross off those 10s, right? They cancel each other out and make 1. So now we end up with 3/10 of a meter. So does this answer make sense? Yes, we thought it would be less than a half a meter, and 3/10 of a meter is less than half a meter. So 3/10, what would that look like in a decimal? 3/10, right? So we're going to write it in fraction form. 3/10 of a meter. So 30 centimeters is 3/10 of a meter. Yes? Yes, it is. Okay, let's move on to problem 2. And this idea, this is not the first time you've seen this. And you have been practicing with your conversion measurements. So this should be getting a little bit easier, but now we're kind of looking at it in the idea of fractions and decimals. So we have 9 inches is equal to how many feet? So let me ask you, which measurement is larger, which measurement smaller? So we're going from smaller to larger again, right? Okay, so how many inches is in 1 foot? There are 12 inches in 1 foot, isn't that right? So think about this for a minute. 9 inches is the same as 9 copies of 1 inch, right? So what fraction of a foot is 1 inch? Well, if you were to draw a tape diagram, and you know there are 12 inches in 1 foot, I'm going to divide it in half and go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Whoops. 6, 7, 8, 9, 10, 11. I'm going to be 1 short. Here's 12. Okay. So here we have a tape diagram. Now, what fraction of a foot is 1 inch? Well, it takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 inches to make 1 foot, right? So 1 inch is 1/12 of a foot, right? So before we rename 1 inch, let's estimate. Will 9 inches be more than half a foot or less than half a foot? Well, half a foot is 6 inches, right? So 1, 2, 3, 4, 5, 6. So half is 6 inches. And we're looking for 9 inches, right? So 9 inches is more than 6 inches. So it will be more than half a foot, right? All right, so let's, after thinking about that for a few minutes, and just having that idea, going through the process of kind of estimating is actually really good as a mathematician to check to make sure your answers make sense. So let's go ahead and write 9. Okay, so let's start here again. 9 times 1, whoops, 1. It's too close together, I don't like it. So 9 copies of 1 inch, right? Now we have 9. Now we're going to convert that 9 times 1/12 of a foot, right? So remember how we converted up here? Our second step was to change our measurement, right? Our unit measurement. So let's rename 1 inch as a fraction of a foot. Now we have written 9 copies of 1/12 of a foot. Are these two expressions, equations, because I threw the equal sign in there, are they equivalent? Yes, they are equivalent. We just renamed the inch in a fraction of a foot. So they are equivalent. So now let's multiply. How many feet is the same amount as 9 inches? So we have 9/12 of a foot. But we need to simplify that. So 3 times 3 is 9, right? And 3 times 4 is 12. Is there anything that we could cross cancel out? Yes, there is. The 3's. So we have 3/4 of a foot. All right. Does it make sense? Yes, it does make sense. Because if we even took this tape diagram and we broke it up into sections of 4, 1, 2, 3, 4, it would take 3 of the fours, 1, 2, 3, 1, 2, 3, 1, 2, 3. So one group, here's 3, 6, 9. We have 3/4 of the foot, right? All right. How about 24 inches to a yard? So what is the larger unit? Well, yards is the larger unit, right? And this is a smaller unit. So how many inches are in a yard? Do you remember that? There are 36 inches in 1 yard, right? Okay, now you don't necessarily want to have to draw out a tape diagram with 36 inches and have it equal 1 yard right here, right? That would be a lot of work. So if this equals 1 yard and you had 24 inches of that, what fraction of a yard do you have? That's what we're looking for, right? A fraction of a yard. 24 inches is what fraction of a yard? That's what we're looking for. Now, Now that we know that there are 36 inches in a yard, let's go ahead and use that same format that we've been using. So let's go 24 inches is equal to, now let's come back over here. It's 24 inches is 24 copies of 1 inch, right? All right, so now we're going to go back to what you know, okay? So 1 inch. So 1 inch would be 1/36 of a yard, right? So just 1 inch would be 1/36 of a yard because there are 36 inches in a yard. And if you just had one, you would have 1/36 of a yard, correct? Okay, so we have 24 copies of, now 1/36 of a yard. So that's where that conversion, that's where we rename it right there. So what is that? We're going to go ahead and multiply and get 24 over 36, right? Okay, but we're not going to leave it like that. What numbers do they have in common so that we can simplify? 12 times 2. How about 12 times 3? We can cancel out the 12s and they become 1. So we end up with 2/3 of a yard. Now, you could take 36 and break it up into thirds and then gather up how many it would take, 24 of it, and then end up with 2/3 of a yard. All right. How is that going for you? Are you able to make this jump right here? Because that's the big idea right here. Can you make that jump? Can you take what you know and know if you have 1 inch, so what would 1 inch be of this larger unit? So 1 inch is 1/36 of that yard. That's that jump you have to make. All right, let's try another problem. Koalas will often sleep for 20 hours a day. For what fraction of a day does a koala often sleep? So, what will we need to do to solve this problem? Well, we'll need to express hours in days, right? So we need to convert 20 hours into a fraction of a day. So, how many hours are in a day? There are 24 hours in a day, right? So, 20 hours is the same as 20 copies of 1 hour, right? So 20. So what am I going to convert this 1 hour into? So if I take 1 hour of the 24 hours of a day, this is where that conversion takes place. So what fraction of the day is 1 hour? It's 1/24th of a day, right? That's why kind of naming this right here will help you as you move along. All right, from here, what do we end up with? We end up with 20/24ths of a day. But are we going to leave it like that? No, we're not going to leave that like that. So let's simplify this. 4 times 5 is 20. 4 times 6 is 24. We can cancel out the 4s and turn that into a 1, right? So our answer is 5/6 of a day. Koalas sleep 5/6 of a day. All right. Is this getting a little bit easier? How are you doing with this? This is the key part right here. this sets you up for solving the rest of the problem. If you can make this jump, you're going to be just fine. Okay, problem 4. Okay, so 15 inches is equal to how many feet? Inches to feet. Compare this conversion to the others that we've done. What do you notice? Well, we're still converting from smaller unit to a larger unit. The last one converted something smaller than a whole day. And this one, though, 15 inches is equal to how many feet? So this is converting something more than 1 foot. 15 inches is more than a foot. So our answer will be greater than 1. We still have to think about what fraction of a foot is 1 inch though. Okay? So yes, the process of converting will be exactly the same, but our answer will be greater than 1. So let's keep that in mind as we work. So how can we start this off? So we know how many inches are in 1 foot. Well, we know there are 12 inches in 1 foot, right? Okay, keep that in mind. 12 inches in 1 foot. But now we have 15 inches. We have 15 copies of 1 inch. What are we going to write next? Did you just say 15 times? What are we going to do? What are we going to do? We're going to say it's 1/12 of a foot, right? 1/12 of a foot. So what do we end up with? 15 twelfths. So we definitely have more. We have an improper fraction. So we know that there's one whole hiding inside of this 15, right? We know there's a 12 over 12. 12 goes into 15. There will be 12 over 12 with 3 twelfths left over, right? So 12 plus 3 is 15, right? So this becomes 1 whole, 1 and 3 twelfths. But you know what? You can simplify that a little bit more, and that is now the expectation. So we're going to keep the 1 whole over here. So 3 times 1 is 3. 3 times 4 is 12, right? The 3's cancel out and become 1. So it's 1 and 1/4 of a foot. So that's how you solve for if it's going to be larger than 1, if your answer is going to end up being larger than 1. All right. So using the same formula, the same strategy of solving, correct? All right, here's the last problem of our problem set. We have 24 ounces, so smaller unit to pounds, right? 24 ounces equal to how many pounds? So going back, what's our first question we're going to ask ourselves? Number 1, are we going from smaller to bigger or bigger to smaller? So here we're going from smaller units to larger units. Now, how many ounces are in a pound? Well, we know there are 16 ounces is equal to 1 pound, right? Okay, so let's start. We have our information we need in order to make that. Now, if you want to see how I actually make that fraction, so I'm going to divide and divide, right? This becomes 1 ounce is equal to 1/16 of a pound. That's kind of how you do it. I assumed you saw that, but let me just show you. That's how I'm creating that fraction. And then pulling it right down there. Okay. All right, here we go. So we have 24 ounces is equal to 24 copies of 1 ounce. Now what are we going to do? Now we're going to take our fraction, right? And we're going to put it in. Go ahead and try to solve this out and come back to check your work in just a second. All right, what did you do? Did you say 24 copies of, here's our 1/16 of a pound, because remember, we're going to pounds, so you have to put those pounds in there. So 24 over 16 pounds. Now, is it going to be greater than 1? Yes, it's going to be greater than 1. Okay, so let's go. 16 out of 16 creates 1, right? And what's left over? 8, right? So 16 plus 8 is 24, right? So this creates 1 whole. So we have 1 and 8/16. But wait a minute. 8/16 is what fraction? It's a half, right? So we have 1.5 pounds, right? All right, so that's going to do it for this concept development. Let's take a look at the problem set. All right, problem set looks exactly like what we've been doing, the way we set it up. Always write down. My suggestion to you is write down what you know. What do you know about that conversion? How many feet in a yard? How many feet in a yard? How many inches in a foot? How many inches in a foot? How many ounces in a pound? How many ounces are in a pound? You're going to complete that. So you're going to express your answer as a mixed number or in simplest form. Let's take a look at the problem, at the word problems, because that is, we are going to convert measures that involve whole numbers, and we're going to solve multi-step word problems. That's our goal today, right? That's our objective. So let's look at the word problems next. You have to be able to solve a word problem because life is filled with problems that are just not super easily solved. It's not just written out. You have to actually think through things in order to solve them. Regina buys 24 inches of trim for a craft project. What fraction of a yard does Regina buy? Okay, this is going back to exactly what you were doing on the page before this. If a whole yard of trim costs $6, how much did Regina pay? So now you're going and you're going to find out how much money she paid for that. Still going back to what have we been doing? What operation were we doing? Multiplying a fraction times a whole number, right? Okay. At Yo-Yogurt, the scale says that Sarah has 8 ounces of vanilla yogurt in her cup. Her father's yogurt weighs 11 ounces. How many pounds of frozen yogurt did they buy altogether? So how many ounces in a pound? Express your answer as a mixed number. So going back to what you know, ounces in a pound. Now, Fenzu drinks 1 cup of milk every day for lunch. How many gallons of milk does he drink in 2 weeks? So how many days in 2 weeks? How many days in a week, right? That's basically what you need to know in order to solve this. And how many cups in a gallon, right? So these are those things that you need to know in order to solve. You should do well. You can look up the whole cups to gallons if you need to. If you don't remember offhand, or kind of work through it as how many ounces are in a cup. So how many ounces are in a gallon? You could do a little division there to find that out. So Take on problem set, come back after you've completed the problem set, come back to check your work so that you can see how you are doing with the concept. You can figure out any fix up strategies, anything that you made a mistake on that you can fix up before you start the homework. All right, I think you should do well on this.